May 27th, 1942. Dawn breaks over the Libyan desert near Bir Hakeim, France. Oberst Hans-Joachim Marseille, the Star of Africa, adjusted his goggles as his Panzer III rolled forward with the rest of the 21st Panzer Division. For over a year, the Afrika Korps had dominated this brutal landscape, turning British armour into burning scrap metal with methodical precision. The Germans had earned their reputation through blood and steel, crushing every tank the British threw at them. The 2-pounder guns on Crusaders and Matildas bounced harmlessly off German armour, while the Panzers' 50mm guns ripped them apart at ranges the British couldn't match. General Erwin Rommel, the Desert Fox himself, had just launched Operation Venezia, a massive flanking manoeuvre around the southern end of the Gazala line. His plan was elegant and brutal: swing wide around the British fortifications, smash their mobile reserves, then roll up the entire defensive line from behind. The Afrika Korps had executed this playbook before with devastating success. Today would be no different, or so they thought. As the morning sun burned away the desert haze, German tank commanders spotted the British 4th Armoured Brigade deployed in defensive positions near Bir Hakeim. Standard engagement, the Germans assumed. British tanks would fire their inadequate guns, German armour would close the distance, and the slaughter would begin. Then something strange happened. German tanks began exploding at ranges that shouldn't have been possible. Obergefreiter Kurt Meyer, commanding a Panzer III in the 8th Tank Regiment, watched in horror as the tank ahead of him simply disintegrated. Not the usual kill where a tank caught fire or had its track blown off. The entire turret separated from the hull, flipping through the air like a toy. Meyer's radio crackled with panicked voices. "They're hitting us from 1,000 metres. What are they firing? Our frontal armour is being penetrated like paper. Where is this coming from?" The German crews had never experienced this. Their tanks were dying before they could even identify the targets. Through the dust and smoke they finally saw them. Massive, ungainly tanks with a profile like nothing they'd encountered before. Towering 10 feet tall, these steel monsters looked like mobile fortresses, broader and heavier than anything in the desert. They sat hull down in defensive positions, and from their right front sponsons 75mm guns were methodically destroying the pride of the Afrika Korps. The British had brought the M3 Grant to war. The story of how this happened began 2 years earlier, half a world away from the North African desert. In June 1940, as German panzers rolled through France and shattered the Allied armies, panic gripped the United States War Department. American tank development had proceeded at a leisurely peacetime pace, based on the assumption that tanks were primarily infantry support weapons. The M2 medium tank, America's frontline armour in 1940, mounted a 37mm gun and weighed barely 20 tons. It was obsolete before it rolled off the production line. The fall of France changed everything. Military observers sent urgent reports back to Washington. German tanks weren't just supporting infantry, they were forming massive armoured spearheads that could penetrate hundreds of miles in days, collapsing entire armies. The panzer divisions had rewritten the rules of warfare, and America's tank force couldn't compete. The US Army urgently demanded a medium tank armed with a 75 leaderless gun. That calibre had proven effective in France, capable of defeating contemporary armour and providing meaningful high explosive fire support. But there was a problem. American industry didn't have the capability to produce a turret large enough to house a 75mm gun. The tolerances required for a rotating turret that size, the casting technology, the manufacturing processes, all of it would take years to develop. America didn't have years. The solution came from an unlikely source, the T5E2 experimental tank, which had been testing a hull-mounted 75 blister howitzer for infantry support. If they couldn't put the gun in a turret, they'd mount it in the hull. It was a compromise, a throwback to World War I design philosophy, but it could be built immediately using existing manufacturing capabilities. The design team at the Ordnance Department had just 60 days to create a functional medium tank. They took the basic structure of the M2 medium, raised the superstructure, mounted the 75mm M2 gun in a sponson on the right side of the hull, and retained the M2's turret with its 37mm gun on top. The result looked bizarre. The 75mm gun could only traverse 32 degrees to either side, requiring the entire tank to turn to engage targets outside that arc. The 37mm turret sat on top like an afterthought, giving the vehicle a towering profile that violated every principle of tank design. The crew of 6 or 7 men, depending on the variant, were crammed into a vehicle that stood 10 feet tall and weighed 30 tons. It was ugly, awkward, and by conventional standards, wrong in every way. But it could be built, and it could be built now. The contract for 1,000 Me-2 tanks was cancelled and replaced with an order for 1,000 M3 tanks in August 1940, even though the final design wasn't complete. Production began in April 1941 at 3 factories: Chrysler's Detroit Arsenal, American Locomotive, and Baldwin Locomotive. By August 1941, M3 tanks were rolling off production lines at increasing rates. The tank came in 2 versions based on turret configuration. The American version, called the Lee after Confederate General Robert E. Lee, had a riveted turret with a machine gun cupola on top. The British version, called the Grant after Union General Ulysses S. Grant, featured a modified turret designed to British specifications. The British had moved the radio equipment from the hull to the turret, requiring a rear overhang on the turret. They also eliminated the machine gun cupola, slightly reducing the vehicle's already excessive height. Britain desperately needed these tanks. By early 1942, the North African campaign had turned into a disaster. General Erwin Rommel's Afrika Korps had arrived in February 1941 and immediately began dismantling British armour. The German tactics were devastatingly effective. Rommel used his Panzers not to fight British tanks directly, but to manoeuvre them into kill zones where concealed 80mm anti-aircraft guns, employed in the anti-tank role, would destroy them at ranges British tanks couldn't match. British tank doctrine emphasised speed over armour, producing cruiser tanks like the Crusader that were fast but fragile. Their 2-pounder guns, 40mm calibre, couldn't penetrate the frontal armour of upgunned German Panzer IIIs and IVs. Worse, the 2-pounder couldn't fire high-explosive shells effectively, leaving British tanks unable to suppress German anti-tank guns that were slaughtering them. The Matilda infantry tank had better armour, but was painfully slow and still armed with the inadequate 2-pounder. British tankers were dying in vehicles that couldn't fight back effectively. American M3 Stuart light tanks had been sent to North Africa under Lend-Lease, and while appreciated for their mechanical reliability, their 37mm guns were no better than the British 2-pounder. Britain needed something with firepower, and they needed it immediately. The British ordered 1,685 Grants directly from American factories under a cash-and-carry arrangement that cost approximately $240 million, essentially Britain's entire liquid assets in the United States. It took the Lend-Lease Act to fund additional orders. The first Grants arrived in Egypt in January 1942. British crews training on them had mixed reactions. The tank was enormous compared to anything they'd driven. The Wright R975 radial engine, a 9-cylinder aircraft engine producing 340 horsepower, provided adequate power but was thirsty, consuming fuel at rates that strained desert logistics. The high silhouette made concealment nearly impossible in the flat desert terrain. The sponson-mounted 75mm gun required exposing most of the tank to engage targets. But the 75mm LEM-2 gun changed everything. For the first time, British tank crews had a gun that could penetrate German armour at meaningful ranges. The M72 armour-piercing shot could punch through 2 inches of armour at 1,000 yards, enough to defeat the frontal armour of Panzer III and Panzer IV tanks. More importantly, the 75mm could fire high-explosive shells, something British tank guns couldn't do effectively. This meant Grant crews could engage German anti-tank guns, the weapons that had been slaughtering British armour. There was a problem with the ammunition. The M72 armour-piercing shell used a base-detonating fuse that was extremely sensitive. It would detonate prematurely if it grazed a target rather than hitting it squarely. This meant rounds would often explode on the surface of German armour rather than penetrating first. When the Grants arrived and began test firing against captured German tanks, the results were disappointing. The shells weren't penetrating as expected. The solution came from an ingenious improvisation. During Operation Crusader in late 1941, British forces had captured approximately 15,000 German 70mm armour-piercing capped rounds. An Australian officer, Major Northey, working with American Ordnance Officer Captain George Burling Jarrett, developed a hybrid round. They mated the German projectiles to American cartridge cases. The German rounds used better fuse designs, and could penetrate the face-hardened armour on newer German tanks. These improvised rounds gave the Grant tank the penetration it needed. By May 1942, approximately 400 Grant tanks were in theatre, distributed among British armoured formations. The 4th Armoured Brigade, part of the legendary 7th Armoured Division, the Desert Rats, received the first Grants. Tank crews trained intensively on the new vehicles, learning to work around the limitations of the sponson-mounted gun. The British defensive position at Gazala consisted of a series of fortified boxes connected by minefields, stretching from the Mediterranean coast 43 miles south to Bir Hakeim, held by the Free French Brigade. The mobile armoured reserves waited behind this line, ready to counterattack any German breakthrough. British intelligence knew Rommel was preparing an offensive. His supply situation had improved, and the Afrika Korps had been reinforced with newer tanks. What British intelligence didn't fully appreciate was that German intelligence knew about the Grant tanks. Captured documents show that German headquarters had issued an intelligence appreciation on May 20th, 1942, 7 days before the battle, describing the M3 medium tank, its 75mm gun, and even noting that British crews had been reduced from 7 to 6 men. The Germans knew the Grant existed. What they didn't know, what they couldn't have known until they experienced it, was what it felt like to face that 75mm gun in combat. On the evening of May 26, 1942, Rommel launched Operation Venezia. His plan called for a feint against the northern part of the Gazala line, while his main armoured force, personally led by Rommel, would sweep around the southern flank at Bir Hakeim. The Afrika Korps would then drive north, getting behind the British fortifications and destroy the British armour in open battle. Rommel had approximately 560 tanks, including 240 Panzer IIIs with 50mm guns and 40 Panzers. The British 8th Army had approximately 850 tanks, but many were obsolete Crusaders and Matildas. The 167 Grants represented the striking power of the British armoured force. At dawn on May 27th, the German armoured columns slammed into the 3rd Indian Motor Brigade south of Bir Hakeim. The Indians fought with desperate courage but were overwhelmed by the Panzer onslaught. The Germans rolled over them and continued north, expecting to encounter and destroy the British armour in the same pattern that had worked for over a year. Then they met the Grants. The 4th Armoured Brigade had taken up defensive positions with their Grants hull down, only the turret and upper hull visible over the ridgelines. When German tanks came into range, the 75mm guns opened fire. At 1,000 yards, ranges where British 2-pounder guns were ineffective, the Grant's shells were smashing through Panzer armour. German tank commanders couldn't believe what they were seeing. Their tanks, which had dominated the desert for 15 months, were being knocked out before they could close to effective range. The psychological impact was immediate and devastating. Major Werner Schmidt of the 5th Panzer Regiment reported, "The enemy possesses tanks with significantly superior firepower. Our advance units are suffering extraordinarily high losses." German combat reports from that day reveal confusion and shock. Crew after crew reported being engaged at long range by heavy guns. When they tried to identify the source, they saw the massive silhouettes of tanks unlike anything they'd encountered. The Grants weren't invulnerable. Their high profile made them easy to spot, and German 50mm guns could penetrate their armour at medium ranges. The infamous 80mm anti-aircraft guns, used in the anti-tank role, could destroy Grants at any range. But the Grants could shoot back, and their 70mm guns hit like hammers. The 3rd Royal Tank Regiment, equipped with Grants, took the brunt of the German assault on May 27th. By the end of the day, they had lost significant numbers of tanks, but so had the Germans. For the first time since Rommel arrived in Africa, German armour had been fought to a standstill. The Germans noted that Grant tanks, even when hit multiple times, often survived. The M3's armour, while not exceptional on paper, was well designed. The frontal armour was 56mm at its thickest, adequate against German 50mm guns at long range. The internal layout, with the main gun and ammunition in the sponson, meant turret penetrations didn't immediately disable the vehicle. More importantly, the Grant's construction was robust. Unlike British tanks that used riveted armour, where rivet heads would break off and ricochet around the interior when hit, the Grant's combination of riveted and welded construction held together better. The radial engine, lacking the vulnerable coolant systems of liquid-cooled engines, could take hits and continue running. Over the next 2 weeks, the battle devolved into a grinding attrition match. Rommel had achieved surprise and gotten behind the British lines, but his supply lines were stretched and vulnerable. British counterattacks failed to dislodge him, but German attacks couldn't break through either. The Grants formed the backbone of British defensive positions, their 75mm guns making any German advance costly. German intelligence officer Major F.W. von Mellenthin later wrote in his memoir, Panzer Battles, "Contrary to a statement in Rommel's memoirs, we did know that the British were receiving Grant tanks. Our intelligence appreciation of 20th of May included a full description. However, their effect in battle exceeded our expectations. The 75mm gun was much superior to the 50mm gun of our Panzer III, and for the first time, British tanks could engage us at ranges where we couldn't effectively respond. The Grant's high explosive capability proved equally important. For the first time, British tanks could engage German anti-tank gun positions effectively. The 75mm high explosive shell, while not as powerful as a dedicated howitzer round, had sufficient blast effect to suppress or destroy dug-in positions. German anti-tank gun crews, who had previously operated with relative impunity against British armour, now faced direct fire from tank guns that could kill them. British tanker Cyril Joly wrote in his memoir Take These Men, "The Grants were twice the size and weight of any tank we had ever had before. They were armed at last with a gun that could fire high explosive, a counter to the dug-in anti-tank guns which had been the cause of so many of our troubles before." The Battle of Gazala ultimately ended in British defeat. Rommel's brilliant generalship overcame British numerical superiority, and by June 21st, the port of Tobruk had fallen. But the Grant had proven its worth. German after-action reports noted with concern that British tanks now possessed firepower superior to most German armour. The battle report from Panzerarmee Afrika stated, "The medium American tanks M3 pilot, which were used for the first time, proved highly able to resist." Rommel himself, in the Rommel Papers, wrote with characteristic understatement, "Up to May of 1942, our tanks had in general been superior in quality to the corresponding British types. This was now no longer true, at least not to the same extent. The psychological impact on German troops was significant. For 15 months, they had known that in tank versus tank combat, they held the advantage. Now, facing the Grant, that certainty evaporated. German tank crews developed a healthy respect, bordering on fear, for the massive American tanks. The Grant's unusual appearance became instantly recognizable, and German crews learned to treat encounters with them seriously. British forces retreated from Gazala to prepare defensive positions at El Alamein, a railroad halt 60 miles west of Alexandria. Here, the British line stretched from the Mediterranean coast to the impassable Qattara Depression, preventing Rommel from using his favoured flanking tactics. Both sides dug in, exhausted and under strength, for what would become the decisive battle of the North African campaign. General Bernard Montgomery took command of the 8th Army in August 1942, replacing the exhausted General Claude Auchinleck. Montgomery, a meticulous planner with an instinct for logistics and training, immediately began rebuilding his army. More Grants arrived, along with a new American tank that would change everything, the M4 Sherman. But at El Alamein, the Grant would have its finest hour. By October 1942, Montgomery had assembled overwhelming force. His army included 195,000 men and over 1,000 tanks. Of these, 170 were Grants, and 252 were the new Sherman tanks. The Sherman was everything the Grant should have been, a proper medium tank with the 75mm gun in a fully rotating turret and a lower profile. But the Grants were still formidable, and experienced crews had learned to maximise their strengths. Rommel, sick with jaundice and exhausted, had returned to Germany for medical treatment. His deputy, General Georg Stumm, commanded the Panzerarmee Afrika with approximately 100,000 men and 489 tanks, many of them inferior Italian models. Only 236 were German Panzers, and fuel shortages meant extended operations would be impossible. On the night of October 23, 1942, Montgomery launched Operation Lightfoot with a massive artillery barrage. Over 1,000 guns opened fire simultaneously, a bombardment that shook the desert and announced that the era of German dominance had ended. British and Commonwealth infantry advanced through the minefields under the cover of this barrage, engineers clearing paths for the armour to follow. The plan called for the Grants and Shermans to push through the cleared lanes and engage German armour in set-piece battles where British numbers and firepower would prevail. The Grant crews knew their role. They would provide the heavy firepower to break through German defensive positions, while the more versatile Shermans exploited the breakthrough. The Battle of El Alamein became a 13-day slog through minefields and defensive positions. German defenders fought with their usual skill and tenacity, but they were overwhelmed by British material superiority. When German armoured reserves counterattacked, they ran into walls of British tanks and anti-tank guns. The Germans lost 50 tanks in their first major counterattack against 1st Armoured Division's Grant tanks. The Grants operated in their element, hull-down defensive positions where their main limitation, the sponson-mounted gun, mattered less. They could engage German armour at long range with their superior 75mm guns while using their good frontal armour to survive return fire. German tankers, already worn down by months of combat and crippling supply shortages, found themselves facing an enemy that now matched or exceeded them in every category. The psychological tables had turned completely. Where German crews had once advanced confidently, knowing their tanks were superior, they now attacked knowing they were likely outgunned. British morale, conversely, had never been higher. They had tanks that could fight German armour on equal terms, commanders who knew how to use them, and overwhelming numerical superiority. On November 2nd, Montgomery launched Operation Supercharge, his final push to break the German lines. The 9th Armoured Brigade, equipped with 40 Grants and 39 Shermans along with Crusader tanks, led a desperate charge against German anti-tank gun lines in what became known as a Cavalier charge into the guns. They were decimated, losing over half their tanks, but the sacrifice achieved its purpose. German defensive positions were broken, and Rommel, who had flown back to take command, had no reserves left to counterattack. On November 4th, facing complete destruction, Rommel ordered a retreat. Hitler countermanded the order, demanding Rommel stand fast, but military reality overruled political fantasy. The Afrika Korps withdrew, beginning a retreat that wouldn't end until the last Axis forces in North Africa surrendered in Tunisia 7 months later. The Grant had played a critical role in both the defensive fighting in June and the offensive victory in October. While the Sherman would become the main battle tank going forward, the Grant had held the line when Britain needed it most. At El Alamein, 246 Grants formed part of the armoured spearhead that shattered Axis defences. Their 75mm guns had proven decisive in destroying German strongpoints and engaging armour at long range. Churchill, never one for understatement, ordered church bells rung throughout Britain for the first time since 1940. "Before Alamein we never had a victory," he famously said. "After Alamein we never had a defeat." The Grant's combat record in North Africa ultimately exceeded all expectations. From its combat debut at Gazala in May 1942 through El Alamein in November, the Grant had proven that American industrial might could produce tanks capable of defeating German armour. Its unusual design, initially mocked by both German troops and British tankers, had proven effective enough to change the strategic balance in North Africa. The statistics tell the story. At Gazala, despite ultimately losing the battle, British forces inflicted heavy casualties on German armour for the first time since Rommel arrived in Africa. At Alam Halfa in September, Grant tanks helped stop Rommel's last offensive. At El Alamein, they helped deliver the decisive British victory. Out of 6,258 M3s produced, 2,187 were supplied to British and Commonwealth forces. In North Africa specifically, 657 Grants were deployed. They served with distinction in every major battle from May 1942 through the end of the African campaign in May 1943. By late 1942, as Sherman production ramped up, surviving Grants were gradually withdrawn from frontline service in North Africa. Many were shipped to the Far East, where they would serve with distinction against Japanese forces in Burma. The British continued using Grants in the Pacific Theatre through 1944, finding them well suited to jungle warfare where their high explosive capability was valued more than anti-tank performance. The Grant's greatest achievement wasn't its combat record, impressive though that was. It was proving that America could build effective armoured fighting vehicles and deliver them in quantities that mattered. The Grant was a stopgap, a compromise design born of industrial limitations and wartime urgency, but it worked. It gave British forces in North Africa the firepower they desperately needed at the exact moment they needed it. The M4 Sherman, which replaced the Grant, was a better tank in almost every way. Fully rotating turret, lower profile, more reliable, easier to produce. But the Sherman's development benefited enormously from lessons learned with the Grant. The 75mm gun mounting, the suspension system, the transmission design, all were refined based on Grant combat experience. More importantly, the production techniques developed to mass-produce the Grant enabled rapid Sherman production. German reactions to the Grant evolved throughout 1942. Initial shock gave way to respect and finally to a grudging acknowledgement that American industrial capacity was a game-changer. German intelligence reports from late 1942 noted that American tanks were arriving in North Africa in numbers Germany couldn't match. Each month, more Grants and Shermans landed in Egyptian ports, while German reinforcements trickled in by convoy, harassed by British naval and air power. Captured German documents reveal their growing awareness that the war of attrition favoured the Allies. One intelligence assessment from November 1942 stated bluntly, "The enemy possesses unlimited supplies of tanks. Our own replacements are insufficient to offset combat losses. Even when we win tactical victories, we lose the strategic battle." The Grant had other limitations beyond its unconventional design. The Continental R975 radial engine, while reliable by 1942 standards, had initially suffered from inadequate air filters. Desert sand would infiltrate the engine, causing premature wear. Engine life was sometimes as low as 25 hours in harsh desert conditions. British maintenance units worked frantically to modify air intake systems, adding sand filters and dust covers. These field modifications significantly improved reliability, but the Grant remained maintenance-intensive compared to British designs. The gasoline engine was a fire hazard. When penetrated, the 90-octane fuel would often ignite, though this was less common than with early Shermans, which earned the nickname Tommy Cooker from Germans for their propensity to burn. Some Grant variants were built with diesel engines, which were safer but less powerful. The crew ergonomics were terrible. 7 men crammed into the original E variant meant working conditions inside were claustrophobic and hot. Desert temperatures could exceed 120 degrees Fahrenheit, and inside the tank conditions were brutal. The British Grant with a 6-man crew was marginally better, but still far from comfortable. The 75mm gun crew worked in the right sponson, separated from the driver and turret crew, making coordination difficult. Communication between crew members required an intercom system that often failed in the dust and vibration of combat. The height remained a constant problem. At 10 feet tall, the Grant couldn't hide. In the flat desert, German spotters could identify Grant tanks from miles away. British crews learned to position their tanks behind ridge lines or in shallow wadis, using terrain to mask their bulk, but this required careful positioning and limited mobility. Despite these limitations, British tank crews came to appreciate the Grant. After years of fighting in undergunned tanks that couldn't penetrate German armour, having a weapon that could kill Panzers at 1,000 yards was revolutionary. The armour protection, while not exceptional, was adequate. The mechanical reliability, after initial teething problems were solved, was better than many British designs. Most importantly, crews who survived their first few engagements learned how to use the Grant effectively. They understood its limitations and worked within them. The tank required a different tactical approach than conventional designs. Grants couldn't brawl at close range. Their sponson-mounted gun put them at a severe disadvantage in turning fights, but positioned hull down at long range, they could devastate German armour before it could close to effective range. British armour doctrine evolved around the Grant's capabilities. Units equipped with Grants learned to fight defensively, using terrain and positioning to maximise their long-range firepower while minimising exposure. This was different from the previous British emphasis on mobility and flanking manoeuvres. The Grant forced British commanders to think in terms of firepower and protection rather than speed. When American forces entered combat in North Africa in November 1942 as part of Operation Torch, they brought Lee tanks, the American variant with the taller cupola and 7-man crew. American tank crews, new to combat, had to learn the same lessons British crews had learned 6 months earlier. The Battle of Kasserine Pass in February 1943 was a brutal introduction to combat for American forces. German forces, though outnumbered and operating at the end of impossibly long supply lines, inflicted a sharp defeat on Green American troops. American M3 Lee tanks, operated by inexperienced crews, were mauled by veteran German tankers who exploited every weakness of the design. American after-action reports were scathing. The Lee's high profile made it an easy target. The sponson-mounted gun limited tactical flexibility. The riveted armour construction meant rivet heads would break loose when struck and ricochet inside the crew compartment, causing casualties even when the armour wasn't penetrated. American tankers wanted Shermans, and they wanted them immediately. But even in defeat, the Lee had proven it could hurt German tanks when handled properly. American units that survived their first battles learned the same tactical lessons British crews had learned. Position. Defensively, use the 75mm guns range advantage, avoid close-range brawls. By April 1943, as the Tunisian campaign reached its climax, American Lee and British Grant tanks were being replaced by Shermans as quickly as new tanks arrived. The M3 had served its purpose. It had given Allied forces a tank with sufficient firepower to engage German armour effectively at a critical moment when no alternative existed. The Grant's legacy extended far beyond its combat record in North Africa. The production techniques developed to mass-produce the M3 enabled rapid expansion of American tank production. At peak production, American factories were completing an M3 every hour. The manufacturing expertise, worker training, supply chain management, and quality control systems developed for the M3 program transferred directly to M4 Sherman production. More subtly, the Grant demonstrated that American engineering philosophy, focused on mass production and mechanical reliability rather than technical sophistication, could produce effective weapons. The Grant was never going to win any design awards. It violated conventional tank design principles, but it worked. It could be built quickly in large numbers, and it could be maintained by reasonably trained mechanics using standard tools. This philosophy of good enough but available in overwhelming quantities would characterize American weapons production throughout the war. Critics, both at the time and subsequently, have dismissed the Grant as an ugly stopgap that succeeded only because of Allied numerical superiority. This misses the point. The Grant was a stopgap. That was exactly what it was designed to be. The entire program was predicated on building something adequate immediately, rather than something perfect eventually. In that context, the Grant was a spectacular success. It bridged the gap between American unpreparedness in 1940 and American dominance in 1943. By late 1943, the Grant had effectively disappeared from frontline service in North Africa and Europe. A few remained in training units, but combat formations had transitioned entirely to Shermans or British-built tanks. The Grant found its second career in the Pacific and Burma theatres. British and Indian Army units fighting in Burma appreciated the Grant's heavy firepower against Japanese bunkers and fortifications. The 75mm high explosive shell was devastating against fortified positions. Japanese anti-tank capabilities were far weaker than German, so the Grant's vulnerabilities mattered less. In Burma's jungle terrain, the Grant's height was less of a problem than in the open desert. Australian armoured units, equipped with Grants, trained for potential operations against Japanese forces, though most Australian Grant units never saw combat. The chassis remained useful even after the tank itself was obsolete. The M31 tank recovery vehicle, built on the M3 chassis, served throughout the war. The M7 Priest self-propelled gun mounted a 105 mm howitzer on a modified M3 chassis and became one of the most successful artillery vehicles of the war. The reliability and load-carrying capacity of the M3 chassis made it suitable for numerous specialized roles. In the Soviet Union, which received 1,386 M3s under Lend-Lease, the tank was less appreciated. Soviet tankers, accustomed to the excellent T-34, found the M3 primitive and inadequate. They gave it the grim nickname, "A Grave for Six Brothers." Soviet combat doctrine emphasized fast-moving armored operations where the Grant's tactical limitations were crippling. Most Soviet M3s were relegated to training duties or secondary fronts. The M3's production run ended in December 1942 after 658 vehicles had been built. By that point, M4 Sherman production had reached over 1,000 tanks per month and was still accelerating. The industrial capacity that had been mobilized to build the Grant was redirected to Sherman production without missing a beat. From a strategic perspective, the The grant's most important contribution might have been psychological. In early 1942, when German forces seemed invincible and the outcome of the war was genuinely uncertain, the grant demonstrated that American industry could produce weapons that could compete with the best Germany could field. This wasn't obvious in 1941 when America entered the war. American military equipment had a reputation for being unsophisticated and unreliable. The grant, for all its limitations, proved that American tanks could slug it out with German Panzers and win. For British forces, battered by years of defeats and inadequate equipment, the arrival of Grant tanks represented a turning point. They finally had a weapon that gave them a fighting chance. The morale boost of operating tanks that could actually hurt German armour cannot be overstated. British tank crews had spent over a year fighting in vehicles where their guns literally couldn't penetrate enemy armour at normal combat ranges. The grant changed that overnight. German intelligence assessments from late 1942 show a growing recognition that American industrial capacity would determine the war's outcome. One captured document noted, "The Americans are producing tanks in quantities we cannot match. Even when technically inferior, which they no longer are, their numerical superiority will overwhelm our forces. Each American tank we destroy is replaced within days. Each of our tanks destroyed is irreplaceable." This was the grant's ultimate legacy, proving that American mass production could tilt the strategic balance. The Grant wasn't a particularly good tank by 1943 standards, but in 1942 it was exactly what was needed. In the final analysis, the M3 Grant succeeded because it solved the problem it was designed to solve. Britain needed a tank with a 75mm gun immediately, and America needed to deliver it using existing industrial capabilities. The result was unconventional, ungainly, and tactically limited. It was also available in quantity exactly when it was needed most, and that made all the difference. The transformation in German attitudes toward the Grant tells the story. In April 1942, when the first Grants were arriving in Egypt, German intelligence dismissed them as inferior to German designs. By June 1942, after Gazala, that assessment had changed to acknowledgement that the Grant possessed superior firepower at long range. By November 1942, after El Alamein, German reports noted that American tanks had achieved parity or superiority over German armour in most categories. The mockery had turned to respect, and respect had turned to concern. The Grant tank's odd design and unconventional appearance made it easy to underestimate. German soldiers initially laughed at the towering profile and the ridiculous sponson-mounted main gun. British tankers, receiving their first Grants, weren't sure whether to laugh or cry at the ungainly monster they were expected to drive into combat. But in the brutal mathematics of desert warfare, where range and firepower mattered more than elegance, the Grant proved itself. Its 75mm gun rewrote the tactical calculus of armoured combat in North Africa, and its presence in overwhelming numbers demonstrated that American industrial might would determine the war's outcome. The laughter died somewhere between Gazala and El Alamein, drowned out by the thunder of 75mm guns hammering German armour at ranges they couldn't match. The Grant had done its job, and in doing so had bought Britain the time it needed to survive. The Grant's combat service in North Africa effectively ended with the fall of Tunisia in May 1943. The final Axis surrender brought 275,000 German and Italian prisoners into Allied hands and marked the complete expulsion of Axis forces from Africa. By this point, only a handful of Grants remained in frontline British armoured units, most having been replaced by Shermans or lost in combat. The tanks that had arrived in January 1942 as saviours were now museum pieces, their tactical obsolescence complete after barely 18 months of service. Yet those 18 months had been critical. Military historians have debated endlessly what would have happened if the Grant had not arrived when it did. In early 1942, with Rommel's forces at peak effectiveness and British armour woefully inadequate, the strategic situation in Egypt was precarious. The Suez Canal, Britain's lifeline to its Asian empire and Middle Eastern oil, lay vulnerable. The loss of Egypt would have severed Britain's connection to India, potentially knocked Turkey out of neutrality on the wrong side, and opened the door to German advances into the oil fields of Iraq and Persia. The Grant didn't single-handedly prevent this disaster. British infantry, artillery and anti-tank gun crews fought with courage and skill throughout the campaign. But the Grant gave British armoured forces the capability to contest German armour on something approaching equal terms. At Gazala, despite the ultimate British defeat, the Grants inflicted sufficient casualties on German armour to slow Rommel's advance. At Alam Halfa in late August 1942, when Rommel made his final attempt to break through to Alexandria, Grant tanks formed a crucial part of the defensive line that stopped him cold. Lieutenant Colonel G.P.B. Roberts, commanding the 3rd Royal Tank Regiment at Gazala, later wrote in his account of the battle, "The arrival of the Grant was nothing short of miraculous. For the first time since I'd been in the desert, we had a tank that could actually kill German tanks at the ranges at which we were being engaged. The psychological effect on the crews was enormous. Men who had been fighting in Crusaders, knowing their guns were useless against frontal armour, suddenly had a weapon they could trust." The technical specifications of the Grant reflected the engineering compromises that made rapid production possible. The hull was constructed of rolled homogeneous armour plate, with thickness varying from 12 mm on the hull floor to 56 mm on the frontal plates. The sponson housing the 75 mm gun had 50 of armour protection, adequate against most German tank guns at medium range but vulnerable to the 88 mm anti-tank guns and the new long-barrelled 75 mm guns appearing on later Panzer IV variants. The 75 mm M2 gun itself was a remarkable weapon for its time. Developed from the French 75 mm field gun of World War I fame, the M2 could fire a 6.3 kilo armour-piercing projectile at 619 meters per second. The high-explosive round weighed 6.6 kg and contained 670 grams of TNT filler, sufficient to destroy or suppress dug-in positions. Maximum effective range against armour was approximately 500 yards, though practical combat ranges were typically between 800 and 1200 yards. The gun's traverse limitation of 32 degrees to either side proved less crippling than expected. British crews learned to position their tanks to maximise the useful arc of fire, and the Grant's relatively nimble handling for its size allowed quick repositioning. The Continental R975 engine produced 340 horsepower at 2400 RPM, giving the 30-ton tank a maximum speed of 26 miles per hour on roads and about 16 miles per hour cross-country. This was adequate, though not exceptional by 1942 standards. The suspension used a vertical volute spring system, VVSS, with 3 bogies per side, each with 2 road wheels. This suspension would be carried over to the M4 Sherman and proved reliable if not particularly sophisticated. Ground pressure was moderate at 13.7 psi, allowing decent mobility in desert sand, though the Grant could still bog down in soft terrain. Fuel capacity was 175 gallons of gasoline, giving a theoretical range of 120 miles on roads. In practice, desert operations with their frequent manoeuvring and idling meant actual operational range was closer to 70 to 80 miles between refuelling. This limited range became a significant factor in mobile operations, forcing British logistics units to establish forward refuelling points. The crew arrangement reflected the Grant's hasty design. The driver sat in the left front hull, with the assistant driver der bow gunner to his right. Both operated 30 caliber M1919 Browning machine guns, the drivers fixed forward and the assistant drivers in a ball mount. The 70mm gun crew consisted of the gunner, loader, and in British Grants, a radio operator who also assisted with ammunition handling. In the turret above, the commander and 37mm gunner operated the top-mounted gun and its coaxial machine gun. This crew separation created significant communication challenges. The 75mm crew in the sponson couldn't easily see what the turret crew saw, and vice versa. Target identification and coordination required constant radio communication between crew stations. In the chaos of combat, with radios failing or overwhelmed with traffic, this could lead to confusion and missed opportunities. The 37mm gun mounted in the turret was not useless, as sometimes portrayed. While ineffective against frontal armour of German medium tanks, it could penetrate side and rear armour at close range. More importantly, it gave the Grant a fully traversable weapon for engaging soft targets, anti-tank guns, and infantry. Some crews used the 37mm as a ranging weapon, firing it first to judge distance before engaging with the 75mm. British modifications to create the Grant variant from the American Lee design improved the tank's combat effectiveness. Eliminating the machine gun cupola reduced height by about 8 inches, bringing total height down to around 9 feet 2 inches, still excessive but marginally better. Moving the radio equipment to the turret improved crew coordination by placing the radio operator with the commander. The British also modified the ammunition stowage, increasing 75 mm ammunition capacity from 46 rounds in the Lee to 58 rounds in the Grant. Armour-piercing ammunition remained a persistent issue throughout the Grant's service life. The standard M72 AP shot, while possessing adequate penetration on paper, suffered from the sensitive fuse problem mentioned earlier. The improvised rounds using captured German projectiles worked better, but were available in limited quantities. British ordnance units experimented with various modifications to improve penetration, including adding ballistic caps to the M72 projectiles and adjusting fuse timing. By late 1942, improved American ammunition began arriving, including the M61 armour-piercing capped ballistic cap APCBC round. This projectile used a better fuse design and a ballistic cap to improve penetration against face-hardened armour. The M61 could reliably penetrate 60 mm of armour at 1,000 yards, sufficient to defeat any German tank in North Africa through the frontal armour at combat ranges. The high-explosive M48 round became perhaps the Grant's most valued ammunition type. British tankers, who had spent years fighting without effective HE capability, used these rounds liberally against German anti-tank guns, field fortifications and infantry positions. The 75 mm HE shell, while not as powerful as a dedicated howitzer round, had sufficient blast effect to suppress or destroy positions that had previously been invulnerable to British tank fire. Operational employment of the Grant evolved as British commanders learned its strengths and limitations. Initial attempts to use Grants like conventional cruiser tanks in mobile sweeping manoeuvres proved costly. The high profile made them vulnerable, and the limited gun traverse put them at a disadvantage in fluid engagements. British armour doctrine adapted, using Grants in more static, defensive positions where their firepower could be maximised. A typical Grant employment doctrine by mid-1942 called for positioning the tanks hull down on terrain features that mask their bulk while allowing clear fields of fire. The 75 mm gun would engage German armour at long range, while Crusader tanks, faster and more nimble, would use their mobility to flank and harass. This combination of Grant firepower and Crusader mobility proved more effective than either tank operating alone. The Grant also excelled in direct fire support for infantry attacks. The 75 mm gun could engage bunkers and fortified positions that infantry couldn't reduce with small arms. During the fighting at El Alamein, Grant tanks frequently advanced with infantry to provide immediate fire support, their HE shells demolishing German defensive positions. Maintenance in desert conditions remained challenging throughout the Grant service life. Sand infiltration damaged engines, transmissions, and running gear. British maintenance units established elaborate cleaning procedures, with tanks receiving thorough maintenance every few days of operations. Air filters were cleaned or replaced daily. Oil changes occurred every 25 to 50 hours of operation, and running gear was inspected constantly for wear. The Continental R975 engine, despite its aircraft heritage, proved reasonably reliable once proper air filtration was implemented. Engine life improved from the dismal initial 25 hours to over 1,000 hours with proper maintenance. The 9-cylinder radial configuration made certain maintenance tasks easier than inline engines, as individual cylinders could be accessed without removing the entire engine. Transmission failures were more problematic. The synchromesh transmission, advanced for its time, required skilled operation and regular maintenance. Inexperienced drivers could damage the transmission through improper shifting, and replacement required removing the engine, a major operation requiring workshop facilities. British units learned to train drivers extensively before committing tanks to combat operations. Track wear in desert sand was severe. The steel tracks would wear through their rubber pads within 500-800 miles of operation, and the tracks themselves would wear out after 1,500 miles. British logistics. Units had to maintain substantial stocks of replacement tracks, and the specialised tools needed to replace them. The Grant's combat debut at Gazala created ripples far beyond North Africa. American military observers, watching British crews fight with their hastily designed tank, reported back to Washington that the M3 was proving effective despite its unconventional design. This validated the decision to rush the design into production, and provided confidence that American armour could compete with German tanks. German intelligence, meanwhile, began warning that American industrial capacity represented a strategic threat. A captured German intelligence summary from July 1942 stated, "The appearance of American medium tanks in increasing numbers indicates the enemy's production capacity far exceeds our estimates. Tank quality is adequate and improving. Numerical superiority will offset any technical advantages we maintain." This assessment proved prescient. By late 1942, American factories were producing over 2,000 Sherman tanks per month, a rate Germany could never match. The production expertise developed with the Grant program enabled this rapid expansion. Workers trained on M3 production lines transitioned seamlessly to Sherman production. Supply chains established to deliver M3 components adapted quickly to Sherman requirements. The Grant's influence extended into American tank design philosophy. The success of the 75mm gun in the sponson mount validated the caliber choice for the Sherman's turret-mounted weapon. The Continental R975 engine, proven reliable in the Grant, was retained for early Sherman production. The suspension, transmission and running gear designs all carried over with only minor modifications. More subtly, the Grant's combat experience influenced American thinking about armour protection. The M3's armour scheme, while not exceptional, proved adequate against German 50mm guns at typical combat ranges. This led to a design philosophy prioritising mechanical reliability and gun performance over maximum armour protection, a philosophy that would characterise American tank design throughout the war. Soviet experiences with the Grant were markedly different from British experiences. The 386 M3 tanks shipped to the Soviet Union under Lend-Lease arrived mostly in 1942, at a time when Soviet factories were producing the excellent T-34 medium tank in large numbers. Soviet tankers, accustomed to the T-34's sloped armour, low profile, and powerful 76.2mm gun in a fully rotating turret, found the Grant's design baffling. The nickname "A Grave for Six Brothers" reflected genuine Soviet concerns about the tank's combat effectiveness. The high profile was a severe liability on the Eastern Front's open terrain. The sponson-mounted gun's limited traverse was a critical weakness in the fast-moving armoured engagements characteristic of Soviet doctrine. The gasoline engine was a fire hazard compared to the T-34's diesel engine. Most Soviet M3s were used for training or deployed to secondary fronts where their limitations mattered less. Some saw combat in the Caucasus in 1942-43, where they performed adequately in defensive operations but proved vulnerable in mobile warfare. Soviet after-action reports noted that the 75mm gun was effective, but that the overall design was inferior to Soviet-produced tanks. This divergence in opinions between British and Soviet assessments of the Grant reflects different tactical situations and doctrinal approaches. In North Africa's desert warfare, characterised by long-range engagements and relatively static defensive positions, the Grant's firepower and armour protection were valuable. On the Eastern Front's vast open spaces, where mobile armoured operations predominated, the Grant's limitations were crippling. The Grant's service in the Pacific and Burma theatres demonstrated its versatility in different tactical environments. British and Indian Army units fighting in Burma appreciated the tank's heavy firepower against Japanese fortifications. The 75mm HE shell was devastating against the log and earth bunkers that Japanese forces constructed throughout the jungle. Japanese anti-tank capabilities in Burma were far weaker than German capabilities in North Africa. Japanese infantry had to rely primarily on close assault tactics, using magnetic mines and Molotov cocktails to attack tanks. The Grant's height, a liability in the desert, mattered less in jungle terrain where long-range visibility was limited anyway. The thick armour protection was more than adequate against Japanese anti-tank rifles and light anti-tank guns. The 146th Regiment Royal Armoured Corps, equipped with Grants, fought in the Arakan campaign in Burma in 1943-44. Their combat reports noted that the 75mm gun was excellent for destroying Japanese bunkers and that the tank's mechanical reliability was acceptable in tropical conditions, though rust and humidity created new maintenance challenges. Australian armoured units received Grants for potential operations against Japanese forces in New Guinea and the Southwest Pacific. However, the difficult terrain in these regions, with its mountains, jungles and limited road networks, made armoured operations impractical. Most Australian Grants remained in Australia for training purposes and never saw combat. The M3 chassis found extensive use in derivative vehicles that served throughout the war. The M31 tank recovery vehicle used the M3 chassis with the turret removed and a crane installed. These vehicles were essential for recovering damaged tanks from battlefields and proved reliable in harsh conditions. Over 200 M31s were built, and they served in North Africa, Europe, and the Pacific. The M7 Priest self-propelled gun mounted a 105 mm M2A1 howitzer in an open-topped superstructure on a modified M3 chassis. This combination proved highly successful, giving artillery units mobility to keep pace with armoured formations, while providing heavy fire support. The 105 mm howitzer could deliver high explosive smoke and white phosphorus rounds to ranges of 11,000 yards. The Priest served extensively in North Africa, Sicily, Italy, and northwest Europe. British forces particularly appreciated the M7, using it to equip their armoured division artillery regiments. Over 3,000 Priests were built, and they remained in service long after the M3 Grant tank itself had been retired. Some were still in use during the Korean War. Other M3-based vehicles included command tanks with enhanced radio equipment, armoured recovery vehicles, and experimental variants testing new weapons and equipment. The chassis' load-carrying capacity and mechanical reliability made it suitable for numerous specialised roles even after the tank itself was obsolete. The Grant's production statistics reveal the scale of American industrial mobilization. From April 1941 to December 1942, American factories produced 6,258 M3 medium tanks in less than 2 years. This included 4,124 Lee variants and 1,334 Grant variants specifically built to British specifications. 3 primary factories produced the M3. The Chrysler Detroit Arsenal tank plant, a massive facility built specifically for tank production, produced 3,352 3s. American Locomotive Company built 685 tanks, and Baldwin Locomotive Works produced 295. Additional smaller contracts brought total production to 6,258 vehicles. At peak production in early 1942, factories were completing 1 M3 every hour around the clock. This production achievement was remarkable considering that none of these factories had built tanks before 1940. The Detroit Arsenal didn't exist before 1940. It was designed and constructed specifically for tank production. American Locomotive and Baldwin were railroad equipment manufacturers that had to completely retool for armoured vehicle production. The speed with which American industry mobilized to build tanks represented one of the war's logistical triumphs. The cost per M3 Grant was approximately $40,000 in 1942 dollars, equivalent to roughly $750,000 in 2025 currency. The British order for 1,685 Grants cost approximately $240 million, a staggering sum that represented a significant portion of Britain's dollar reserves. The Lend-Lease Act, passed in March 1941, eventually provided the funding mechanism for additional orders, but the initial Grant purchase strained British finances severely. Production ended in December 1942 as Sherman production ramped up. The last M3s rolled off the assembly lines and were immediately placed in storage or shipped to training units. By early 1943, no new M3s were being manufactured, and factory capacity was entirely devoted to Sherman production, which would eventually total over 49,000 tanks. The Grant's retirement from frontline service occurred rapidly in 1943. In North Africa, surviving Grants were consolidated into training units or shipped to other theatres as Sherman deliveries increased. By the Tunisia campaign's end in May 1943, virtually no Grants remained in combat units in North Africa. The last combat use of Grants by British forces in the Mediterranean theatre occurred during the Sicily invasion in July 1943, where a few tanks still equipped rear echelon units. In Burma, Grants continued to see combat through 1944, though they were progressively replaced by Shermans and British-built Churchill tanks. The final British combat use of Grants occurred in early 1945 during operations in central Burma, where a few tanks remained in service with Indian Army units. These last Grants were finally retired mid-1945 as the Burma campaign concluded. The historical assessment of the Grant has evolved over decades. Contemporary observers, seeing the tank's ungainly appearance and unconventional design, often dismissed it as an inferior stopgap. German accounts written after the war downplayed the Grant's effectiveness, emphasizing instead the superiority of German training and tactics. Post-war British military historians, focused on later developments like the Sherman and Churchill, treated the Grant as a brief curiosity. More recent historical analysis has given the Grant greater credit. Modern historians recognise that the tank appeared at a critical moment and performed its intended role effectively. The Grant was never intended to be a war-winning design. It was meant to give Allied forces adequate firepower until better tanks could be developed and produced. By that measure, it succeeded completely. The Grant demonstrated several important principles that influenced subsequent weapons development. First, getting adequate weapons into production quickly can be more important than waiting for perfect designs. The Grant was available in May 1942. The Sherman didn't arrive in quantity until late 1942. Those 6 months mattered enormously. Second, combat effectiveness depends on the entire system, not just technical specifications. The Grant's unconventional design worked because crews learned to employ it properly and logistics units kept it running. Third, mass production and mechanical reliability can offset technical limitations. The Grant was never the best tank in any category, but it was available in large numbers and could be maintained under field conditions. These lessons influenced American weapons development throughout the war and beyond. The philosophy of good enough available now in overwhelming quantities characterized American production of everything from trucks to aircraft to ships. While critics argued for more sophisticated designs, American military leaders consistently prioritized production volume and mechanical reliability over technical perfection. The Grant tank stands as a monument to industrial improvisation and wartime urgency. Born from America's unpreparedness in 1940, rushed into production in 1941, it arrived in North Africa in early 1942 at exactly the moment British forces needed it most. For 8 critical months, from Gazala in May to El Alamein in November, the Grant provided the firepower that allowed British armour to contest German Panzers on approaching equal terms. Its design was ungainly, its limitations were significant, and its combat life was brief. But in those 8 months, the Grant helped turn the tide in North Africa, demonstrating that American industrial might could produce weapons capable of competing with the best Germany could field. The mockery and doubt that greeted its arrival turned to respect as the 75mm guns hammered German armour at ranges they couldn't match. In the brutal arithmetic of desert warfare, the Grant proved that firepower and numbers could overcome elegance and sophistication. It bought Britain time, gave Allied forces hope, and paved the way for the Sherman tanks that would help win the war. In the end, that was exactly what it needed to do, and history should remember it accordingly.